Email, but I have it. Okay, thank you. Hello. Okay, everyone. It's 11:30, and I'm going to start the lecture today so I can hopefully finish chapter 7. Before I start, I wanted to show you two things. So first is the book that I hope most of you now have access to the book, and if you still don't have access to the book, since it is free and it's really good for you to learn the materials well, I highly recommend you to get the book. And as you can see, it has like the feature that it can also read the book for you. So you see,
molecules. Since we do not ordinarily deal with individuals,
I guess
7.1
yeah, you see.
volcanoes, automobiles, and laundry detergents.
So even if you're like on the way or like you have some time that you want something to listen to, you know, your book can be a really good substitute for music or podcast or anything that you listen to, you know. So I just wanted to show you this feature and also all other features that it has. And if you just go to your BBLearn, if you click on Camp e-text, you see these, and then you can go to study area, mastering assignments, and for each chapter it has like assignments, and then basically if you go to the e-text, it had like worked examples and so many cool features. So this is one thing. The other thing is that I realized since so many of you wants to get extra credits and increase your grades, I'm receiving so many emails, so it became so hard for me to manage them, and then it takes longer than I expected to add your extra grades and all that. So for that matter, I created homework assignments. So from now on, I appreciate if you go to BBLearn and then click on each specific homework that I specified. And for each day, for instance, today, I'm assigning homeworks for you. So it would be like November 3rd, and it has the deadline. So you don't get confused which one is which. And if you have any questions about that, just let me know. Or if you didn't know how to upload them, yes?
Say that one, we'll start doing it after today.
Yes, yeah. So I already sent some of you the emails that I got your email or corrected you. if you had any mistakes in your solution. And then I'm going to grade rest of you that sent me emails last night or today, or the ones that I didn't go through. But from now on, I appreciate that if you just upload your solutions, the pictures that you send me through email in BBLearn. And if you couldn't figure that out, it's still fine to email me. But this is kind of easier for me to keep track of, and I can go back, grade the ones that I already have, and then make sure that I'm catching up with all the emails. Any questions about these two things? The book and also BBLearn. Okay, the other thing that I wanted to tell you is your tutoring session. So to encourage you to go to your tutoring sessions, because I highly believe that it increases your ability to learn and kind of like basically it would be a good practice for you all, I'm going to assign some extra points for people who go to tutoring sessions. And the way that I do that is that I add 10 points to your exam 3 or exam 4, so what I do is that when I add all your grades, and it's out of 800, right? You had like, you'll be having 4 exams total, 1 final exam, and 4 quizzes, right? And the sum of all of those are like 800. I add 10 points to that for anyone who shows up to tutoring sessions. And the way that I keep track of that, I just ask your tutor, Laura, and then ask her, give me a list of people who usually show up to tutoring sessions. And then you can communicate with her about that. And if you cannot make it to those hours, basically Wednesday 6 to 8 and Thursday 6 to 7, right? If you cannot make those times, just talk with her so she can accommodate you. If she couldn't, talk with me. I schedule tutoring sessions for those of you who cannot make those sessions, because I want all of you to get that extra credit as well. Is that clear? Any questions? Yes?
As we get closer to exam 4, will you start holding your own sessions as well?
Yes, yes. I wanted to do that for this week too, but I was just like grading so many things, and yeah. But also, I'm going to send you a when to meet link too. So, right now, if you need my help, just email me and I schedule office hours for you. And I also have my normal office hours after the class all the time. So that is fixed. Monday, Wednesday, Friday, 12:30 to 1:30. I'm always having those office hours. But I add more office hours for you guys so you can reach out to me and ask me any questions that you have. Okay, so if no question with that, I just wrote here that if you can just upload your homeworks on BBLearn. And the other thing that I wanted to mention, if, I had students emailing me that they didn't do quizzes of chapter 5 and 6, self-assessment quizzes in their textbook, basically from their textbook in BBLearn. So if you didn't do that, you still can do that, and I give you the 5 points extra credit, because I just want you guys all to learn, and I want you guys to be motivated, and I do my best to make that happen. Any objections about this? Are we all good? Okay. Yeah, of course. Any questions from last week? Okay. Can anyone tell me what was an acid-base reaction? Yes?
The reaction that has an acid plus a base that resulted in creating a water and sometimes salt.
And what?
And sometimes a salt.
Yes, exactly. So we have acid, we have base, and the product, as your friend mentioned, it would be water and a salt. So I'm just going to write that here. Acid plus base gives water plus salt. And the other thing that we mentioned was gas. So that was acid base reactions. And then gas evolution reactions. Can anyone tell me what was gas evolution reaction? So you can just guess from the name. So what would be produced? Exactly. And I told you that we have like two types. In one type, there are like gas being produced just from the reactants directly. In the other type, first, an intermediate product being formed, and then that product produces gas. So now, and then I gave you some examples last week. So I'm going to ask you, this one would be as your first assignment. So I'm just trying to be clear for you guys, so when you, and I just like mark them here as numbers so you won't get confused. So this would be like homework, one of your homework problems. Complete the following chemical equations so that they produce gases. So for each of them, you'll see a gas. And all of the homework problems that I'm assigning is directly from the book. So if you just study the book, go through the examples in each section and also solve the examples, you'll be fine. But feel free to email me. I'll be more than happy to explain the problem to you, walk you through the problem, because that is my main goal. So that they produce gases, and name all of the chemical species you see. And then these are your equations. HC2H3O2 aqueous plus NaHCO3 aqueous. The other one is HCl aqueous plus NaHSO3 aqueous. NH4Cl aqueous plus NaOH aqueous. And the last one, 2HCl aqueous plus K2S aqueous gives the product. So these are all gas evolution reactions that you should see a gas being produced at the end. So I'm asking you to complete these chemical equations, and afterwards name all the species, reactants, products, anything that you see, name them. So naming them would be chapter 5, but writing these equations would be from what we learned. Okay? So something important about gas evolution reactions is that many gas evolution reactions are also acid-base reactions, because in lots of them you'll see water being generated. So and acid, so basically they produce a gas, but the reactants are an acid and a base that they produce water. So remember, many gas evolution reactions are also acid-base reactions. And in general, something about multiple choice questions, that you should always remember. Most of the time, if you see all, for instance, if I tell you, and I asked you this in your previous exam too, that all of the ionic compounds contain metal. When you see all, usually in nature we have exceptions. There are like really, really rare instances that a statement is all the time true, So if you see if I gave you this statement, true or false, all gas evolution reactions are also acid-base reactions. Is it true or false? Yes. So always be suspicious if you see extreme words, like all. This is always the case. Usually, in nature we have exceptions. So remember, many gas evolution reactions are also acid-base reactions. And now, I'm giving you the second homework problem. So I just write it homework 7, or 2. Second, and this is, I put like a homework by it, so it would be obvious that this is the second question that I'm asking you. So you have your table 7.4, and that is types of compounds that undergo gas evolution reactions. So what I'm asking you is just write that table, because I just want you to see those reactants and then what they produce. So I just want you to write that table. So that is easy. Just go to that table and then write that table for me. Write table 7.4 and name all the species you see. So, here. Okay, so here is your table 7.4. So you see that if your reactant type is sulfide, and then you won't be having intermediate product that I mentioned, and then you see H2S. Can anyone tell me the name of H2S? Yes, hydrosulfuric acid. And what type of acid is that? Can anyone tell me? We had 2 types of acids, right? One was binary acids, the other, do you remember? Exactly. So since here we have just hydrogen and sulfur, there are 2, it would be binary acid. So I'm asking you to just write this table and name all the species you see. Any question about that? So just go turn off this light. Okay. If you're all clear, okay, I just go to oxidation reduction reactions. So we talked about these types of reactions, or specifically oxidation reactions, very briefly when I was just starting the chapter and talking about different types of reactions. Can anyone tell me if they remember what it was, or if not, can anyone give me an example of oxidation reaction? Yes? Yes, exactly. So if you have anything that is made of iron and then you put them in water or in a humid place, after some time you see rust on it, right? So that is an example of oxidation reduction reactions. And in general, the definition of the oxidation reduction reactions are the following: that these types of reactions, they involve transfer of electrons. So you have one element or compound that transfers electrons to the other compound. So we call those oxidation reduction reactions. So I'm just going to write the definition here for you. Reactions involving the transfer of electrons are called oxidation reduction reactions. And some examples are rusting of iron, bleaching of hair. So now you know that if you bleach your hair, there is some sort of chemical reaction happening, and that is oxidation reduction reaction. Or production of electricity in batteries. So for instance, if you have like hydrogen plus oxygen gives water. And remember, balancing the equations, we make sure that the number of atoms on left side of the equation equals number of atoms on right side. So we have like 4 hydrogen here, we have 2 oxygen, 2 oxygen. So the equation is balanced. So this reaction powers the space shuttle. So there are 3 ways to distinguish oxidation reduction reactions. One way is if you just see a compound reacts with elemental oxygen. The other one is if you see a metal reacts with a non-metal. And the other one is if you see a reaction, basically the general definition, that it involves transfer of electrons. So I'm going to write this too because it is important for you to distinguish different types of reactions from each other. So redox reactions, and that is stands for oxidation reduction. This is kind of like oxidation reduction. So we call them redox to be concise. Redox reactions are those in which, I'm gonna write this with red. 1. A substance reacts with elemental oxygen, or a metal reacts with a non-metal, or more generally, one substance transfers electrons to another substance. So for instance, if you see 4Fe solid plus 3O2 gas gives 2Fe2O3 solid. So if I ask you, I give you in the exam and I ask you which type of reaction is this? Can anyone tell me what type of reaction is this? So what do you see? Yes, exactly. You see oxygen, right? And remember, if you see one substance reacts with elemental oxygen, that would be oxidation reduction reaction. So let's give another example. If you see 2Na solid plus Cl2 gas gives 2NaCl solid. So what type of reaction is this one? What is it? Exactly, because we said if we have a metal reacts with non-metal, we'll be having oxidation reduction reaction. So we have metal and non-metal, right? Or, for instance, if you have For some reactions is not as easily as C, but right now we don't worry about them. For now, if you see oxygen or if you see metal reacting with non-metal, you can be quite certain that you have oxidation reduction reactions. So now I'm going to give you the third homework problem. And as I said, these are first I'm assigning more for you to study, have a better understanding, know where your problems are. If you don't know, what is your difficulties. And I want to increase as much as possible grades for your exam 3. So that's why I'm trying to assign more homework problems. Besides, all of them are from the book. So if you just study the book, you should be able to answer them. They're not like trick questions or anything that you didn't see before. So, and this is homework problem 3. Write chemical equations for rusting of iron, combustion of natural gas, and formation of table salt. So rusting of iron, combustion of natural gas, and formation of NaCl, table salt. Okay? Any questions about anything that I talked about? Okay. The fourth homework problem. Solve example 7.13 from the book. And it gave you some reactions and asked you which type of reaction is that and why. And that is really important for you to be able to distinguish different types of chemical reactions and to be able to write the chemical equations. Okay, so right now, so far we had like 4 problems, meaning that if you solve them, you have increased your exam 3 4 points. Okay? Now, if no questions so far, we're going to talk about combustion reactions. Can anyone tell me what is combustion reaction or give me an example of a combustion reaction? Anyone? Yes. Yes. So in your car, the gas or diesel or whatever the fuel is being burned, and it generates lots of energy, lots of heat, and it's a form of combustion reaction. So generally in combustion reactions, we have like a substance reacting with oxygen and generating oxygen containing species. Okay? And most all the time we have like lots of energy being produced as well. So I'm going to write you the definition. Combustion reactions, and combustion reactions are a type of redox reactions because they involve transfer of electrons. So combustion reactions are a type of redox reaction. They are characterized by the reaction of a substance with molecular oxygen to form one or more oxygen containing compounds. Often including water. For instance, you have like combustion of burning of methane. And in lots of combustion reactions, you have CO2 and water being generated. But it depends, there are like combustion reactions that you don't see any water or any carbon dioxide. But if you have like hydrocarbons, that we're going to talk about them in like next chapters, if they burn, you see CO2 and H2O. And now I'm going to give you the 5th homework problem. Complete the following. So some of these were supposed to be for the previous session, so that's why the last one was 1, for this one is 5. Complete the following combustion reactions and balance the equation you write. So these are the combustion reactions, the reactants. C8H18 plus oxygen gives C2H5OH liquid plus oxygen gas gives carbon solid plus oxygen gas. For instance, here you don't see H, so you won't be having any species, including water, that contains hydrogen on the right side. So this is an example of a combustion reaction that doesn't necessarily generate water because you don't have hydrogen on the left side. Hydrogen gas plus O2 gas gives. This is another example that you don't see carbon on left side, so you won't be seeing any species containing carbon on the right side. And then CH3OH liquid plus O2 gas. As I mentioned, all of these are taken from your book, so don't worry. As long as you listen to the lecture, read your book, you're completely fine. And email me if you have any difficulty with any of this. I schedule Zoom meetings with you or in-person meetings with you, walk you through everything that I talked about in the class, and just don't stress out about anything. Just like try your best to learn. Any questions? Okay. So everybody good with this? Can I go to the next page? Okay, I guess I just write here. Next section is classifying chemical reactions. So based on the reactions that we talked about so far, can anyone tell me that how many reactions did we study, or like name them? So what did we just talk about? Exactly. What else did we talk about? Exactly. Redox reactions. What else? What's that? Exactly. Combustion reactions. Yes? Oh, sorry. So we had like acid-base reactions, right? We had gas evolution reactions. We had redox reactions, combustion reactions. Anything else? Precipitation reactions. Do you remember precipitation? We had like two, solvents, or like two solutions that we add them together, we see a solid, right? So this is one way to categorize chemical reactions. So if we have like chemical reactions, we can categorize them based on type of chemistry occurring during the reaction. So based on what sort of chemistry we have, for instance, in acid-base reactions, we have neutralization of an acid with a base. Or like in redox reactions, we have like transfer of electrons, right? So this is the type of chemistry that is involved. And based on that, we can have like these reactions. We have like precipitation. We have acid-base reactions. We have gas evolution reactions that you remember many of gas evolution reactions are acid-base reactions, remember. And oxidation reduction reactions, which one category of oxidation reduction reactions are combustion reactions. So I'm going just to write it such this, combustion reactions. So there is another way to categorize chemical reactions, and that is based on what atoms or group of atoms do during the reaction. So let me just write it and then I explain it to you. So we have like the other category or the other way to categorize chemical reactions in this way. What atoms or groups of atoms do during the reaction. So one type is, we call it synthesis or combination. So we have like two simple groups of atoms. They react with each other and then they form a more complex compound. So in simple wording, you have like A plus B gives AB. So I'm going to write these down and then give you example for each. So we call this one synthesis or combination. You have like one group of atoms, they combine with the other groups of atoms and they form more complex compound. The other one is AB gives A plus B. So we call this one decomposition. So basically you have a complex compound that is decomposes, it separates to simpler compounds. So it's kind of opposite of synthesis in a sense, if you think about it from like perspective of what atoms of group of atoms do. It's kind of like first in synthesis or combination, you have like two groups of elements or like two groups of atoms, they combine. In the decomposition is the reverse. You have a complex compound that it decomposes, it separates to simpler compounds or elements depending on the chemistry or like the compound you're dealing with. And the other one is A plus BC gives AC plus B. And we call this one single displacement. Basically one element, here you have A, here B, C. So one element substitutes the other elements. So you will be having A that reacts with C. So you'll be having AC and then B dissociates by itself. The other one is AB plus CD would be AD plus CD. B. So this A substitutes this C, and then this, so you'll be having, so if this A substitutes C, you'll be having AD. And then this C substitutes this A. They switch positions. It would be like CB. So two elements or groups of atoms substitute the other element or groups of atoms in the other compound. So we call this double displacement. So I'm going to write you the definitions really quickly. So synthesis or combination. Simpler substances combine to form more complex substances. Is this clear what combination is? So we have simpler substances. They combine, they form more complex substances. Okay, is that clear? And then we have decomposition. Reactions. A complex substance decomposes to form simpler substances. So you have a complex compound that is decomposes to simpler compounds, kind of opposite of synthesis. In single displacement or displacement reactions, one element displaces another in a compound, and in double displacement, two elements or groups of elements in two different compounds exchange places to form two new compounds. So, knowing these, I'm going to write you some examples. That's not what I intended. Okay, that's what I intended. Okay, So can anyone tell me what, in the sense of, as we said here, what atoms or group of atoms do during the reactions? In that sense, if we want to categorize these reactions, what type of reaction is this? Exactly, we have synthesis or combination. Why? Exactly, because we have like sodium and chlorine, they react with each other and then they, form one compound, another substance. What about the second one? Exactly, we have decomposition because we have like one substance that it decomposes to its constituent elements. So this one would be decomposition. What is this one? Yes, so you see you have like, here Mg, here HCl. So this Mg substituted hydrogen. So you have MgCl. But remember, when you want to write ionic compounds, you should consider their charges and make sure that the ionic compound is neutralized. So that's why we put 2Cl. So anytime when you have a reaction and you want to write the right side, the products, remember, you just see what elements you have. So in this case, you see Mg and then HCl. So if they are to react with each other, you should substitute Mg with H. So you should write a compound that has Mg and Cl. But just don't write MgCl because you should remember Mg is in group 2A, right? It always has charge of +2. And chlorine is in group 7A. It always has charge of -1. So in order for Mg and Cl to form an ionic compound to be neutral, you should write 2Cl, okay? And then if you want to balance the equation, you just change the coefficients as we talked about. And here, hydrogen, you just don't write atomic hydrogen. If you remember, we had like some elements that they would be molecular elements like O2, H2, Cl2, Br2, I2. Do you remember? Okay. So this would be single displacement. So what about this one? Exactly, because you see this H substituted this Na, so you'll be having a substance that has H and CO3. And again, writing acids. Remember, you have like your hydrogen as if, it has basically, when it decomposes in water, it has, or what I mean is that if this salt solves in water, you'll be having hydrogen plus and Cl minus. And for this one, you'll be having Na plus CO3 2 minus. Do you remember writing complete ionic equation? That is basically what I asked you during last homework. And then here you'll be having H plus CO3 2 minus. Here Na plus Cl minus. So this hydrogen reacts with or like bonds with this CO3. And here you see that you have charge of +1, here charge of -2. That's the reason here you have like 2 hydrogen. And then NaCl, since both of them have just one charge, you just write NaCl as such. But regardless, this hydrogen substituted this Na here. So you have a compound with hydrogen and CO3. And here, this Na substituted this hydrogen, so you have like NaCl. So that would be double displacement. And if you go to your book, for each of these types of reactions, it has like so many examples. So this is finally your 6th homework problem. Write 4 chemical equations for each of the above categories. And if you just go to your book, section 7.10, you know, it has like several examples for each of these types of equations. So you can just write those from the book. So to be clear, I want you to write for synthesis or combination, for decomposition, for single displacement, and for double displacement. And I'm going to write this like this so you.
So can we copy them out of the book, or do we have to
Yes,
do more?
yes, I just want you, when you write them, as I said, all the homework problems that I'm giving you are from the book. So you're welcome to refer to book, and I highly encourage you to study them, and if you don't understand anything, ask me, because my ultimate goal for you guys is to learn. If I wanted to ask you something that you don't know how to, I wouldn't give you something from the book. I just want you to learn. And the other thing that I wanted to address is that, when I listen to my lectures from time to time, I realize that it seems that I'm shouting. I just want to, because I move a lot, I just want to make sure that I'm recording what I'm telling you for later use, or people that I just watch the videos from home. So I just don't want you guys to think that I'm like unkind or just like yelling. So I'm just trying to record the best quality that I can, because this is the big room. So thank you. Yes. No, that's the previous one is fine. This is from now on. Yes, sure.